Hello everyone, I hope you're doing well. In this video, we're going to be looking at an algebraic way to solve for the point of intersection of two lines. I found this question in the McGraw-Hill-Ryerson textbook, Functions 11, Chapter 1, Prerequisite Skills, Question 5. If you want private tutoring with me, or you want to enroll in my Grade 11 Functions course, visit my website, tutor.ca. Okay, so what we want to do is we want to look at these two linear equations, right? So both of these equations here, each part of this question gives us two linear equations. And we want to figure out where these two lines intersect each other, but we want to do it without drawing the picture. We want to do it algebraically, which means, just using the symbols and the numbers that are given to us. The reason we might want to do this is because graphically, if you try to draw a picture, it's hard to see exactly like what is the solution, some decimal, right? It's hard to tell by graphing if it's some fraction like that. Or what if the solution is somewhere like way over here? Then you're gonna have to draw a huge graph, right? So graphing is really only useful in certain situations where the answers are whole numbers and near the origin, right? So we want to be able to do this algebraically. And generally, the way that I like to teach this is by substitution. Okay. So there is another method, substitution. Just make sure I spelled that right. So substitution is the method that I think makes the most sense. So let's take each line here, y equals 3x plus 5, okay, and the other line, 2x minus y equals 6. And I like to show that they're together by this little bracket like that, just shows that they're together, okay? So we're thinking about the system of two equations here. Okay, so the way we want to solve this is we want to make sure both of the equations are written as y equals mx plus b. They want to be both in slope-intercept form. Okay, so the first one is, and now we just got to take the second equation and turn it into slope-intercept form. So 2x minus y equals 6. The way I'm going to do that is I just want to solve for y, right? So what's in the way of y being alone? Well, okay, so 2x is certainly in the way of y being alone. So I'm going to subtract 2x from both sides here, right? That will cancel. I'm going to have negative y equals negative 2x plus 6. And I don't want negative y, I want positive y. So what I'm going to do is I'm going to multiply both sides by negative 1. But what you can think about when I multiply both sides by negative 1, what I'm really just doing, an easier way to think about it is I'm just going to flip the signs of everything. So it's going to be y equals positive 2x minus 6. So positive y equals positive 2x minus 6. Just flip the sign of everything. Same thing as multiplying both sides by negative 1. Either way, we're going to rearrange this and we're going to get our new system, y equals 3x plus 5, which is what we had from before, and y equals 2x minus 6. From here, to solve, we want to remember that we are looking for some point where these two lines intersect, and that point has an x value and a y value. What's the x value? Well, we have a way of representing it in here, right? These two symbols represent the x value, and similarly, right, these two symbols represent the y value of that point. So remember, this is a particular number. Y is a particular number. So if that particular number is equal to 3x plus 5, and that particular number is also equal to 2x minus 6, then 3x plus 5 must be equal to 2x minus 6. Okay, those must be the same number because they're both equal to y. So we get 3x plus 5 equals 2x minus 6. I just took the right side of both of those equations. At this point, what I want to do is I want to solve for x, right? I can solve for x here because I only have one equation and one unknown variable. So I want all the x terms to be on the same side. So what I'm going to do is I'm going to subtract 2x from both sides here. Those will cancel, and I'll be left with 3x minus 2x plus 5 equals negative 6. I'm going to subtract 5 from both sides now to make sure that all the numbers are on the right side. So 3x minus 2x is just x. These cancel. So this is going to be negative 11. And there is the x value of our solution. And now to find the y value, we'd go back up to either one of these equations up here. It doesn't really matter which one, right? Let's just take the second one for convenience. So I'll say solve for y. And we want to, we know y is equal to 2x minus 6. Since I know x now though, right? Y is now equal to 2 times negative 11 minus 6. So y is negative 22 minus 6. 2 times negative 11 is negative 22. And y is negative 28. So we found that the solution to the system is negative 11, negative 28. That's the point that these two lines intersect at. And you see, it's good that we did this algebraically because that would be really hard to graph, right? That'd be pretty far away from the origin. That's it for part A. Let's move on to part B. Okay, so part B is even simpler because the lines, okay, the lines are already written in slope-intercept form, right? Y equals mx plus b, y equals mx plus b. So all we have to do immediately at this point, you can just, I like to draw the bracket just to show that they're kind of together. If we're doing this by substitution again, substitution, right? We just take the right side of both equations and set them equal to each other because they're both equal to y. Okay, so x plus 4 equals 2x minus 1. Again, I want to get x alone, so I'm going to move this x term to the other side. And I'm going to do that by subtracting x from both sides. So we're going to have 4 equals 2x minus x minus 1. And then I'm going to add 1 to both sides. So it's going to be 5 equals 2x minus x is just x. And those are going to cancel out. So we figured out our x value. X equals 5. Now, I want to find my y value by going back to either equation. I'll go to this first one because it's a little bit simpler this time. Y equals x plus 4. Okay, well, I know what x is though, right? Well, x is 5. So y equals 5 plus 4. Y equals 9. And so our solution to the system is 5, 9. The point 5, 9. That's the point of intersection of these two lines like that. Okay, that's it for part B. Let's go to part C, the last part of the question. So part C, notice they are both in standard form, right? So at this point, you could try the elimination method. Okay, so I'll do this example using the elimination method. Now, elimination. Now this is not substitution, right? So we will not be rearranging for y equals. So in elimination method, you actually want them to be in standard form. And there's essentially two main rules of elimination method. Okay, so the first main rule is you can multiply an equation by any number. Okay, not 0, but any other number. And you can add together, or you can add or subtract equations, okay, to create new ones. So these rules kind of seem random, and you know, there's elimination method is usually a tricky thing to try to get around. And so these rules are true. They might not seem true. I personally, when I was learning this, I think the second one was very surprising to me. But it does work. So let me show you how you'd use these rules to actually solve this question. Again, I like to just draw this little bracket to show that they're together, but I'll draw it over here. So x minus 2y equals 7. 2x minus 3y equals 13. So we're doing this by elimination method. You could do this by substitution method by rearranging both of these into y equals mx plus b and using and then substituting the right side, you know, making the right sides equal to each other, like we did in the previous two examples. For elimination method, what you want is you want to choose what variable you're going to eliminate. I'm going to choose x. Okay, I'm going to choose x to eliminate. And what I want is I want the number in front of the x variable to be the same in both equations. So they're not right now, right? It's a 1x over here and it's a 2x over here. So what I can do is I can use rule number 1 and I can take this row and multiply it by 2. Okay, so remember I'm allowed to multiply an equation by any number. Okay, so now my new system is 2x minus 4y equals 14. Right, so I've multiplied everything by 2. And now again, 2x minus 3y. This equation didn't change, right? And then what I want to do is I want to subtract these two equations to get a new equation. Okay, so I'm going to subtract these two. Maybe I'll write the little subtraction here, right? And that's part number 2 here. I'm going to add or subtract them to create a new equation. Okay, so 2x minus 2x, 0x. Negative 4y minus negative 3y. Okay, well that's negative 4 plus negative 3, right? Sorry, negative 4 plus 3 is what I meant to say. Negative 4 plus 3 is going to be negative y, right? Negative 4 plus 3 is just going to be negative y. Okay, and then 14 minus 13 is just going to be 1. And so 0x, the reason this was any help is because 0x is just 0. And so we learned that negative y equals 1, or in other words, y equals negative 1. And we solve for the y value pretty simply there, right? So you see, elimination method has a lot fewer steps than substitution method, but I think they kind of seem more random. But here's an example. So now we found the y value, and now I want to find the x value. So once again, I'm going to go to either of the starting equations. Let's say x minus 2y equals 7. But remember, I know what y is. So x minus 2 times negative 1 equals 7. Just replace y with negative 1. Okay, so x plus 2 equals 7. Okay, because negative 2 times negative 1 is positive 2. And I'm going to subtract 2 from both sides. So we learned that x equals 5. And the solution to the system is 5, negative 1. And we can do a quick verification of this, make sure this is actually true. So if I go to Desmos here, okay, and I type in these equations, so we have, what was it? It was x minus 2y equals 7, 2x minus 3y equals 13. And we should see that the point of intersection is, in fact, at 5, negative 1 there, right? See, 5, negative 1 is that point, and that's where the two lines cross over. And we figured it out algebraically using elimination method in this case. Okay, that's all for this question. I hope it was helpful. If you want private tutoring from me, or you want to enroll in my grade 11 functions course, visit my website, tutor.ca. Thank you so much for watching. Have a nice day.